All right, so let's start it. Action plan for today's talk. I hope I'll make some sense. So there'll be two parts for this talk. First part is a bit of theory and talk, and I'll talk about observability and in particular OpenTelemetry, open source project. It's pretty hot at the moment. Some parts of it and its components. And then we'll go to actually interesting thing, demo, coding, and I try to structure my demo in a very simple way that you can just go to this repository, follow along, and just copy this code and use it in your application project. And I limit it to Ruby and some gems. I spiced it up with some Sidekick and maybe Rack. I didn't go into Rails or any fancy stuff, so I tried to keep it super simple. And yeah, let's get onto it. And I apologize in advance if I have some technical issues. This is not my laptop since there is a news. I'm just borrowing it. But yeah, about me, my name is Anton, also known as Friendly Ants. I'm engineer, software engineer, 10x junior engineer, aspiring developer advocate. And since Monday, I think I'll be like a Saul Goodman of tech. In my hobbies, as I said before, kitesurfing, camping, art photography, motorcycling. This is my website. You can go here if it loads. This is some stuff you can know about it. This is some of my pictures I took ages ago. This is some stud trail in South Australia above my tent. So this is me. So let's dive in. Let's talk a bit about theory and why I decided to do this talk. If you heard that, my previous talk, I said that, I committed last year and this year to do test drive my code. Most of my code should be test driven this year. And earlier this year, I think Michael said that TikTok, they don't do tests at all. They don't have a concept of extensive testing. They, if they have a bug, or something happens in production, everybody kind of drops the tools and fix this bug, and that's why they don't really need tests. Say again? Oh yeah. And I kind of started to massage this idea, and somebody said, they could only do it because they have good observability. They have like good insights what's happening there. Because if you don't know that your code is broken, users will just uninstall your app before you know. So yeah, so basically observability gives us ability to detect, that something is going wrong with our system, without going into console or going into our code base and trying to understand what caused this issue. And in order to do that, we need to instrument our code. So instrument our code, we put some code in it that emits logs, metrics, and traces in a standard way, and we can pipe it to a system, and it's all done automatically. So we can ask those questions: why this is happening? But in the modern world of ship it, we don't test drive it; we're just shipping it. There are so many services. You go to tender with the client and say you need more microservices. You have a nice monolith. But you need more microservices, and you go into this tailspin of building more and more microservices, and that makes the system quite distributed. And for that, you need a distributed tracing. That basically you collect a log from your Ruby application, then you send it to a database, SQL or Sidekick. And then you can capture it as a chain or a trace, and it's all kind of presented in a consolidated manner as a part of single flow. So if user logged in, you navigate it to this page, you click this button, something blew up, and you can see it as a part of the big picture. Essentially kind of you want to see everything in this distributed kind of distributed tracing way. So there's a concept of spans in OpenTelemetry. When you have a big span, you say, this is my application, user logs in, this is a session, and he goes into different flows like, pay, go to database, and it's all captured. And then you can see it in a, like here, in the subspans, and have a root cause analysis of the problem if something goes wrong. So, and essentially OpenTelemetry is a framework to help us do that, to instrument our application. Official definition of OpenTelemetry, it is a collection of tools that basically help us to emit those signals in a structured way. And by signals, we mean our mostly common logs, Rails logs, metrics, which means how many requests per second we do, and traces. Traces is the most interesting part, and that's what we're going to do and to demonstrate in this talk. Traces essentially, those spans that I showed you, that you can do a root cause analysis. OpenTelemetry project started by merging of two projects, Open Census by Google and Open Tracing. As I said, it's open source, it's vendor agnostic. It's part of Cloud Native Computer Foundation since 2019, and it's the second most active project there. It's still in a very early development, kind of active development, not early development, but it's still quite raw, and documentation is quite hard to grasp, and it's constantly changing. So I'll try to consolidate it here and show you in my demo what it can do. It has a lot of high caliber contributors from Google, GitHub. So I believe this project has a lot of potential. Let's dive into parts. What makes up OpenTelemetry? The way I see it, there are two layers to it. Basically, it's a specification. Specification say, let's agree to name things in a certain way. This is pretty much code of conduct, whether we're going to name the data in a certain way, that we have some semantic conventions for our API, SDK, and the rest based on this specification is called implementations. One of those implementations is instrumentation. Instrumentation is a keyword in OpenTelemetry observability terms. It's basically a set of tools or libraries for every language, whether it's Ruby, Rust, JavaScript, that you can just plug and play into your app. Require a gem, and your application will be emitting correct signals in OpenTelemetry compatible standard. There is a collector concept as well. Collector is considered as like an agent that runs in your system, and it takes the data from a Datadog, for example, or OpenTelemetry or Prometheus or other data provider, formats in a certain way and pipes it to another data provider like a Datadog or a Splunk. As I said, specification is across language requirements and expectations. It defines the rules for API, SDKs, and data requirements. In particular, I want to point out a semantic convention. Semantic convention is pretty big on OpenTelemetry. It defines common terms for common web items. For example, if you have a web browser that user is using to access your website, generally it's called user agent, and OpenTelemetry defines a specific way to name it. So no matter what language you're using, it will be in a, it will be written in a consolidated certain way that you can refer and use it across any languages, across any libraries. And there's another concept of resources. Basically, it means it's your environment or Kubernetes cluster or your computer, your Docker instance. Basically, you can do isolation of the problem. Say, this problem happened in this environment, in this cluster, and basically it happens with this browser version. That's how you can narrow it down. Pretty common stuff. You can do it in any other project, powerful project like a Datadog, but OpenTelemetry is an open source project, and it's an alternative to those. As I said, instrumentation is an implementation of this specification. They say, let's agree to name things in a certain way. And basically, it's like a gem. In Ruby, it's you just require this gem, install it to your app, and you're pretty much good to go. You don't have to do extra code. If you want to do some extra custom telemetry, you can do it manually, but generally it's automatic. And there's a link to this library by OpenTelemetry, and you can see there's a lot of automatic instrumentations like for action pack, for active job, for AWS SDK, for DALI, Faraday, SQL, Postgres, Rake, so on and so forth. And it's constantly evolving, and you can see it's very very fresh. Collector, as I said, consider it as a agent for your machine. I won't talk much about it, but generally I look at it as kind of data pipeline. You take a data from one data provider, you can filter it out, you can spice it up, you can add attributes to it, and you can direct it to other data providers, where it's a Jaeger, Prometheus, Datadog, OTLP, which is part of OpenTelemetry. And I think that's it with this boring theory. Yeah, I apologize if it was a bit too dry. So I guess we'll dive into demo. And yeah, I'm glad you liked it. Yeah. Anyways, we'll start with the basic Ruby demo. It's a vanilla Ruby implementation. You can just go to this repo, bundle it, and just run this Ruby basic script. So, but before we do it, I'll probably show you what the script looks like. And it's all it is. So line number 1, this is OpenTelemetry SDK. As I said, this is a bare minimum just to require this gem to say we're going to do this OpenTelemetry standard. And then somewhere in your environment, you have to kind of define explicitly where you're going to send this telemetry data. We'll start it with the console. So we'll basically run this command and everything will be output in our console. As I said, you can send it to Datadog, to Jaeger, to any data collector, data provider backend. On line 5 to 7, this is bare minimum that you need to configure. OpenTelemetry SDK configure, just give it some name. If you don't do it, it will be unknown name, but yeah, I highly recommend doing it. So, and that's all you need to do manual kind of OpenTelemetry, in open to comply with OpenTelemetry standard. On line 9, we create our own custom tracer. So tracer is a kind of wrapper around your script or application. So let's say my app tracer that will be called la-di-da tracer. That's what we define on line number 9. And we say, let's do this trace. And in this trace, we'll create a span that is called the basic work. And it's a single span trace. And we'll do some code, these 4 lines, which just do some puts, sleeps, and does made it at the end. And I use this gem colorize. Highly recommend to look at this gem colorize to have some colorful output in your terminal, so it will be easy to distinguish between things. Any questions before we go?
Yeah. Why is it sleep at 6.3 seconds?
Yeah, good question. Yeah, basically, I'll touch later on it in this lecture. Jaeger backend. Jaeger backend needs some time to catch up. And I did it like, something more than 1.3 seconds or something, as I figured experimentally on my machine. I think it's more than a second, to be honest. But 6 is just to kind of have a look what's happening and talk through it. But we can dial it down. It doesn't have to be 1.3. What?
I thought you were going 3.14.
Yeah. No, it was just random. Yeah, a random observation. I had no idea because basically I was running the script and everything was output into the console. But if you run some Datadog or some fancy backend with the UI, they don't go to your UI because your UI doesn't have time to catch up. The Ruby is executed too quickly, and that was the reason, just to give it some time to sleep. Anyways, let's get back to it. So yeah, as I said, we just do Ruby basic single span, and basic operation. So we're doing some work, we're sleeping, and let's scroll up. Yeah, basically we start this span, we sleep, and then we finish it. And when we finish the work, we create this struct that has OpenTelemetry SDK, span data, trace with the span data. That is called the basic work. That's what we called it in our app. And it has all this OpenTelemetry specified data in, as I said, in a grid specified way. It will be unified across every apps. It will be compatible with any other language. You can see process runtime version. This will be identical as per semantic convention in any language. So that's all you need to do. This is pretty much a manual instrumentation. The next step, I guess, we can go deeper and show send some telemetry to UI. Some of the backends for OpenTelemetry, basically OpenTelemetry is a standard, as I said. It's not like a tool that you can install. It's an instrumentation for your language, but it doesn't really give you a UI to look at it. It's not like a Sidekick web UI that you can look. You need to install a separate application for that. One of those applications is a Jaeger. It's called a Jaeger. There are quite a few of those apps. Jaeger is my go-to. It's written in Go. It's quite fast, and that's how you install it. Docker run. It's currently running. You go to this port 16686, which I think is open here, and you can see this UI when you can navigate, and yeah, we'll come back to it later. So this is our backend where we send our telemetry. And I'll show you this complex operation. So basically what we do here, I'll put this gem colorized at the top. We do this same thing, OpenTelemetry SDK. This time we define our exporter specifically. We say use Jaeger as exporter. There are other exporters as Zipkin and other formats, OTLP. And then we change traces exported from console to Jaeger. So everything goes to this backend. And then we call it complex service. And we'll do the same thing. We'll create a my app tracer for manual instrumentation that called la-di-da tracer, let's say, but the service will be called complex service. And in this this tracer, we'll do kind of the same, but with the several child spans. So we'll have a parent span that is called complex process parent span, and within this span we'll have 4 processes, child spans. Child span 1 called calculation. The second span will be database query. Third span will be web request, and the fourth span will be Sidekick. So we'll be able to see all these spans and processes, in a consolidated way in one page, when we can see the timestamps, when it started, when a calculation started, then it went to DB query, when the web request was made, what happened there, and it will be all presented in OpenTelemetry standard way. And I'll probably expand it here. Calculation is pretty simple. We would just do hex digest, some calculation, we clock it and put some text in the terminal. With SQL query, I tried to kind of build some slow query. It doesn't really matter what we do. And then we'll put a database search has been finished in a console. And in the next span, we'll just do a web request using net HTTP, using DuckDuckGo. And in fourth span, which is quite interesting, we'll use a Sidekick. So we'll schedule a Sidekick job here. So Sidekick job, which is defined in another file, we'll just, schedule a job to perform a sync. And I highly recommend you to, if you use a Sidekick, to always use perform async. Never use perform that or perform now, because it overloads Sidekick. The best practice for Sidekick is to use perform async, and Sidekick figures out itself when it needs to do it. And So Sidekick schedules this job. I hope I didn't didn't lose you yet. With the Sidekick job, we'll demonstrate automatic instrumentation. With this, where we require Sidekick, we require colorize, and here you see on line 7, we start to use instrumentation called Sidekick. It can be Rails, it can be Rack, and that's all you need to do for automatic instrumentation. You just require this Sidekick gem instrumentation, and you do the same. OpenTelemetry Jaeger, you call it, service name, and use instrumentation Sidekick, and everything will be picked up automatically here. You don't need to do any spans like I showed you before, any of this mumbo jumbo. You can do it in Rails, just plug and play. So, and that's what I'm doing here. I do generic stuff, for the Sidekick, configure client, specifying Redis databases. You don't have to worry about that. And then I define the Sidekick simple job class. Job includes Sidekick worker, and we perform something, we sleep. Basically, I have, a scenario when this Sidekick job can fail. So basically, if we roll 1 out of 3, we'll raise an error, overworked error. So basically, OpenTelemetry will be able to capture it, and we'll be able to see it in our backend. So let's get onto it finally. So in order to do it, you need to run a Sidekick job, a Sidekick server, I guess. Sidekick server is run by running command Sidekick with the flag -r to require a file. And what I figure out when preparing this presentation, when you require a file for the Sidekick, you have to do a / for the folder, because if you don't do / and just do multi-span, it won't detect this file. So let's do that. Let's run it here. So we have a Sidekick server running this job, and let's run our Ruby multi-span script. So basically what we'll do, as I said, we'll do this 4 operations: calculation, web request, DB query, and schedule a Sidekick job. And you'll see it in a Sidekick here, and Sidekick will be able to pick it up and process it. So cool. We have a green line for this mathematical calculation. It's picked up. Then we've done a DB search, and then we made a web request, and then we did a Sidekick job scheduling. On the right tab, you see here, we have a lone error. Basically, we went into the scenario when this job failed. So basically, it says, I'm doing something super hard, and we expected a message of success, but we didn't get it. We get this lone error message, which is quite vocal. But basically, Sidekick will reschedule this job, and as you can see here, it rescheduled this job and successfully finished it. I finished doing something hard, it says here. So we've done it in OpenTelemetry way. We use some manual instrumentation and automatic instrumentation for Sidekick. So let's see finally how it looks in web UI. So Sidekick service, yeah. I'm seeing only Sidekick service, but I'll give me a sec. Exactly. Yeah, maybe. Yeah, maybe you're right. Yeah. Maybe you're right. Yeah. Jesus. Yeah. Anyways, yeah. But before we continue, I'll probably show you what the Sidekick span. Basically, Sidekick service, as we saw, it failed first. It was failed. It marked as a fail service, and then it retried, and it showed it as a Sidekick with its OpenTelemetry tags, and you can see it's has its proprietary semantic convention key value pairs. It has tags, it has processes, and it will be compatible with any backend, with any data collector. You'll use it. What I'm surprised to see, I don't see complex spend like with the manual instrumentation. Maybe you're right. So basically, complex job should send it to maybe it will pick up. No, it doesn't. Right, wrong.
Where to send the traces to.
Basically, we define at the top. So I say, in our file, we require this OpenTelemetry Explorer. So we say we use this Jaeger gem, for exporting stuff. And then in our environment variable, we say use Jaeger for exporting data. Maybe I need to kind of.
So this looks for
Yeah. 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 So, how do I save it? Yeah, let's go. Yeah. I couldn't figure it out. I was like, oh, must sleep. How do I copy? Yeah, this is Mac. This is not Linux. I was like, what's going on? Yeah. Yeah. Hopefully it will pick up, but that's one of the problems I encountered. Oh yeah, thanks a lot. Yeah, now we have 4 services. So yeah, it took me like literally 2 hours to figure it out. Imagine doing this, and it's like it outputs to the console, and it's like it doesn't come in Jaeger. It's like cool, but it is one of those caveats. I'm not quite sure. But yeah, finally, this is the goods. So we see this complex service, and we see this concept of spans, that we have a parent span that basically it's our complex process parent span that we call, that has the subspans. That first span is called calculation, that took almost a second. Yeah, it's pretty slow machine, Michael. Yeah. Then we did a DB query, slow DB query that took 790 milliseconds. Then web request was pretty quick, DuckDuckGo for the win. And then Sidekick job that took only 68 milliseconds, but basically it means that Sidekick job was scheduled. It doesn't mean that it was complete. And that's why we have this long parent span that was waiting. I think. No, sorry. Yeah, I'm lying. So this long span specifies the sleep that is not wrapped into this manual instrumentation. But basically, this parent span captures the whole time and all these child spans that it took. So we can try to, and we can go, as I said, they're all connected. We can do debugging of the Sidekick service if something goes wrong. We can click on span ID, and I think it has a link to parent span somewhere. References follows from span ID. So basically, it has a references, and it has a connection to its parent span that it's called. So it still remembers that it's part of the largest span. So basically, if you use this automatic instrumentation in Sidekick and you use it in Rails as well, you'll be able to connect two dots quite easily, because they're all connected, interconnected. You don't have to. Correlations IDs, I don't really know how it does, but basically it's quite deep into OpenTelemetry. Yeah, go into it. There's definitely correlation IDs, but I think there's more to it.
If it's the same as Datadog,
Yeah, could be. What I know, yeah. From my understanding, some of these libraries are quite low level and written in C. So yeah, I wasn't able to fully grasp it. But that's essentially it. That's the basic of it. Back to presentation, I guess, if you run out of time. What's the summary? Yeah, we can pretty much enable OpenTelemetry. Use this automatic instrumentation, just dump in our code, and we'll have compatible standard with a lot of vendors like a Datadog, Splunk. They all support OpenTelemetry. It can be automatic or manual, as I showed you. It's future adoption. I think it's it's looking at the rate how it's developed and evolves. I think it will be industry norm in a couple of years. All major providers and vendors that are compatible with Datadog. So if you, or with the OpenTelemetry, so you have a Sentry, Datadog, they're all compatible. You just replace Datadog with OpenTelemetry, and there will be no issue for you to migrate to other vendor or provider. As I said, it's still in active development. It's a bit hard to understand what documentation says because there are so many components. They have come up with the new features and new terms. For most languages, they focus on traces. Metrics and logs are yet to come. That's not only like for Ruby. Rust is still kind of in development for metrics, but traces is the main focus here. Yeah, and I've got a note here to challenge Anton to do another talk as well. Yeah, he promised the other day. So yeah, I hope it wasn't too overwhelming. For resources, you can go to OpenTelemetry.io to know more about it. Jaeger tracing, this is the backend that I showed you. The other backends like Zipkin that you can use. There's a YouTube tutorial by Nginx, and there is an official OpenTelemetry demo. It's link number 4, provided by OpenTelemetry. Basically, they provide a shopping app that written in multiple languages like Java, Ruby, Rust, and it has different services. And mail service is written in Ruby, and it plays nicely with other languages. And you can see what you saw here, but in a multi-language paradigm. Yeah, I think this is it for me. Yeah, unless you have any questions. Yeah. Here. Yeah.
anyway.
Is there a way to attach additional information to your top level span? Like, let's say that you want to attach
Yes.
additional metric data.
Great question, because I wanted to demonstrate you, but I thought, oh yeah, I'm kind of taking so long. Definitely you can do it. OpenTelemetry allows you to do a lot of stuff with it. I can show you what I've done here that I haven't demonstrated yet. So here I have another demo with the rack app. That pretty much does very similar thing. Here I use rack with instrumentation for rack. As I said, this is automatic instrumentation and it does everything. And the way you do it, I have a similar kind of logic here. And then I create on line 8 tracer, and I create this line 10 tracer span. Rickroll calls the span. This is a parent span. And on line 11, I set custom attributes. I say, here we go as a key, and let's roll as a value. So you can do whatever you want. I can roll to 100, I can do this span set attribute. It's done in this fashion. This is pretty abstract and quite freely interpreted key value pairs. What you can do instead of here we go, you can use semantic convention. You can say HTTP user agent in a defined way specified in OpenTelemetry, and it will be whatever you say here as your web browser, and it will detect on any backend as a web browser of your choice. So you can override it, you can set attributes. I highly recommend going to the OpenTelemetry documentation page, which will tell you all these quirks about setting attributes, but that's what you can do. Yeah, you can saturate your spans with additional data, with any data you want. Yeah.
Yeah, the use case I'm thinking of is like, even in our case, we have a bunch of cyclic jobs that log out a bunch of additional information that probably wouldn't really sit well within this kind of context instead.
Mhm.
But happy with the fact that job ID, so we can filter out.
Yeah. Yeah, it can be. The way I see solution for your problem is the concept of a collector for OpenTelemetry. So say you've got the sidekick thing, sending it somewhere, and then, or you have an OpenTelemetry collector sitting in between and say, I'm going to consume and pull this data, or you can push into this collector. You can filter those attributes out, then you can saturate it with additional attributes, and then you can pipe it to whatever you want. You don't have to send it to your main data backend. You can just send it, here's a specific sidekick backend, and that's what you're going to do. I haven't dived deep into collectors because I thought I'll just focus on basic instrumentation. This is more than enough. Yeah, and yeah, I think that's the way to do it. Yeah. Anything else? Yeah.
Your demo, so only the sidekick job running once, is that because it just happened that it did retry that particular one? Like, wasn't the dream here to show that not complete span sidekick is going to run a number of times?
I wasn't able to do it. So basically what you're saying, you have to see.
Yeah, there's only one of those.
Yeah, basically I wasn't able to, I tried to do it. Basically, when you do perform a sync, Sidekick gives you a confirmation message that I schedule this job and I walk away. I wasn't able to do it as a kind of one span. I was able to see it in a.
Right, so and then the follow-on question was, how do you pass on that ID? So presumably there's some kind of span ID that if we had passed on to that job, then that job when running would have also said, oh, I'm part of this bigger span.
Yeah, and that's exactly what you do. So basically you go to Sidekick service, you find this job, one of this error as we saw before, and that's the most recent one, Sidekick service, one span. And it's part of its own span. And then you can go into details and references and find this, the parent. Yes, yeah, good question. I'm pretty sure if I was able to look at, yeah, let's see it. Span ID. No, it doesn't seem to have a baggage. I don't see it. There's another concept apart from metrics, logs, and traces that I encountered on reading documentation. It's called a baggage, which changes names quite constantly in OpenTelemetry. And I believe that's actually the thing that you're asking for. It's pretty fresh. Basically, it says, I'm going to assign to this job a baggage, and it will be carried out no matter what. So I believe that might be a solution here.
The terminology. I just want to distinction between the spans change the terminology. Figure, sorry,
So I think that's what you're asking for, like, your baggage, right? When you have a parent span, and then you have a child span, another child span, and then it kind of links, and then you can go from this parent span to this subspan. Right. I think that's it on that note. If there are no any questions, yeah, yeah.
You provide a meme creation service.
Meme creation service, yeah.
Top quality memes.
Yeah. Thanks. Yeah. I wish, yeah. Just DuckDuckGo it. Yeah, my pleasure. I'm glad I enjoyed it. All right. Thank you, guys. Yeah.